Hello everyone, welcome to my channel, and I think in this session we will be enriched with the concepts of alcohols, phenols and ethers. There is a basic structural difference between alcohols and phenols, though both have OH functional group. Some are categorized as alcohols, rest are categorized as phenols. So which type of compounds are alcohols? What are their properties? Which type of compounds are phenols? If we are given two compounds having same OH functional group, are we able to distinguish them by chemical test? So yes, we should be able. So let's explore new concepts. Hello everyone. When we are discussing regarding the topic of alcohols and phenols, there is something common in them. Alcohols and phenols actually they have this OH group attached in their structure. For alcohols in the aliphatic system, there is OH attached. That means to the carbon hydrogen chain, there is OH attached. For phenols in the aromatic system, suppose a benzene ring is there. In the aromatic benzene ring, there is OH directly attached, and such a compound is known as phenol. What is the linkage for ether? Ether means carbon, oxygen, carbon linkage. This linkage is known as ether linkage. So in order to understand the compounds in organic chemistry, we need to understand the linkages. Next, after this, we have classification of alcohols, phenols and ethers. So for classification part, I hope you remember in the previous modules regarding classification of haloalkanes and haloarenes. Whatever we said, here also the thing remains same. That is classification based on number of OH atom. Based on number of OH groups rather. So we can say it can be mono when there is one OH. It can be di when there are two, tri when there are three. That means they are what? Other than one OH group, for 2-3 OH groups, they are polyhydric compounds. Means there are more than one OH group attached to their structure. Now, for monohydric alcohols, there are certain classification based on the hybridization. So classification based on hybridization of the carbon atom which is having the OH group. The carbon having OH can be sp3 hybridized also, sp2 also. That is what we have seen in the previous modules for haloalkanes as well. If this carbon is sp3 hybridized, then they can be primary, secondary, tertiary alcohols. So for sp3, we can see 1 degree alcohol, 2 degree alcohol, 3 degree alcohol. So carbon atom having OH is directly attached to one more carbon. So this carbon can be of course one alkyl group. So I'll write one R here. That's why I have replaced that carbon. So valency of carbon is 4. So left over 2. So this is it. So the carbon atom having OH is directly attached with one carbon. It is 1 degree. Directly attached with 2 carbon, then it is 2 degrees. So R and the other R dash whatever. And here is the fourth, that is H. So see, it is 2 degree because there are 2 alkyl groups are there. Here it can be 3 degree when it has 3 alkyl groups, same or different. Just for the sake of the example, I am giving you same alkyl groups. So these are the 3 alkyl groups attached to the carbon having OH, which is the functional group. Other than this, we have certain positions where if the OH group is attached, then it becomes allylic alcohol. That means in the allylic position, there is OH group attached. So this is the allylic position. If I say, then this is of course sp3, and it is attached to carbon which is sp2. So here is a carbon which is sp2, and this is your allylic position, and this will be an example of your allylic alcohol. Now this allylic alcohol can have two hydrogen atom or may not have two hydrogen atom if it is substituted. So this again can be a primary, secondary and tertiary. Now after allylic position, there is another position where the carbon atom having the functional group OH is sp3 hybridized, and that position is your benzylic position. And in the benzylic position, the way we have seen in the previous sessions, that is the carbon atom which we are telling is benzylic is having the functional group and is directly attached to the aromatic ring or directly attached to sp2 carbon which belongs to the aromatic ring. So again this carbon can be a 1 degree, 2 degree or 3 degree, like in case of allylic we have seen. Now after this was about sp3 carbon which is holding the functional group. Regarding sp2, that means the carbon atom, this carbon having OH is sp2 hybridized. Now this again can be vinylic. It can be vinylic. So the way we have seen previously, carbon atom having OH, that is the functional group, is sp2, then only it is vinylic. But this sp2 carbon is not belonging to any aromatic ring. If it belongs to any aromatic ring, then it will become phenol. So if it is sp2, it can be vinylic, else it can be phenols, where we can see that carbon atom which is having OH, yes, it is sp2, but this sp2 carbon belongs to the aromatic ring. So if OH is directly attached to the aromatic ring, then such a system is a phenol system. It's not alcohol. So for phenols, again I will say these phenols can be mono, can be di, can be trihydric phenols, depending on how many OH groups are attached to it. So just like we have seen in case of alcohols here, that is di and tri are known as polyhydric alcohol. So obviously di and trihydric phenols, they are polyhydric phenols. Now when we talk about ethers, ether linkages, I said, is R, O, R or R dash, because it is having carbon, oxygen, carbon linkage. Now if both the side of the oxygen atom there are similar alkyl groups or same structure, then this type of ethers are known as symmetrical ethers. And if on both sides of oxygen there are dissimilar groups, different structure, then they are known as unsymmetrical ethers. Unsymmetrical ethers. So these are ethers. So example of symmetrical ether, CH3O, CH3. The other one unsymmetrical, CH3O, C2H5. This is unsymmetrical. Let us now move on to nomenclature. Nomenclature of alcohols and phenols. Now alcohols are the derivatives of alkanes. We can say why, because in an alkane is RH. If I replace this H by OH, it is alcohol. So alcohols are named as alkanols. Why? Because this was alkane and I drop this E and I add O. Such system are known as alkanols. Methanol, ethanol, propanol, in that way. Now, when I say methanol, ethanol, it has methanol as one carbon atom, so it's CH3OH. Ethanol, CH3CH2OH, 3 carbon atom. Propanol, CH3CH2CH2OH. But When I say 4 carbon atom, 3 carbon atom can be aligned in this manner only, having OH here. Suppose this is it, CH3, CH2 and a CH2OH. So the numbering will be from the side where OH is attached. So this is carbon number 1. The name is propanol or propan-1-ol. But this 3 carbon atom may be aligned in this manner, having the OH in carbon number 2. So I can say CH3, CHOH, CH3. This is having an isolinkage. So the common name is isopropyl alcohol. And this is your common name, but not the IUPAC name. Previously, this was your IUPAC name. Now, what will be the IUPAC name of this compound? Left and right, any side you can start numbering. Both the side you will get 2 position OH. So, the IUPAC is propan. I will not write propane. E is dropped. 2 all. Propan 2 all. And moreover, keep in mind 2 vowels over here. Here E and here O. O, both are vowels facing each other, so E is dropped. This way you can see, or you can see the way I said, ki alkanes are named as alkanol. So it is like this. Next, the next example is, say there are 4 carbon atoms. If there are 4 carbon atoms, then you have one possibility, CH3, CH2, CH2 and a CH2OH. This is 4 carbon atoms, straight chain, N-butyl system, and the IUPAC name is butanol or butan-1-ol. 4 carbon atoms may be aligned in this manner also, 1, 2, 3, 4. And the OH group, I can change the position. So if I change the position of the OH group, I have given to this carbon atom, which is a 2 degree, we can see. On both the side, it is having 2 carbon atoms. So it's a 2 degree. So here I am writing CH3, CH2, CH, OH, CH3. Now if you see this, the carbon atom having OH is a 2 degree. In total, they are having 4 carbon atoms. So it is a secondary butyl alcohol. It's a secondary butyl alcohol, which is the common name. But what is the IUPAC name? Obviously, I have to number it from the right hand side to get the carbon atom having OH, the lowest number. So it becomes what? It becomes butan-2-ol. Some write it as 2-butanol. I'll insist to write butan-2-ol because butane is the parent. You drop the E and bring a butanol system. To this butanol system, you have OH at position 2. So better to write butan-2-ol. Now suppose in this butyl system again, I write it in this manner. These are the 4 carbon atoms because I have changed the branching. And to this carbon, I am giving OH. So, I have got an isolinkage because like this only we write isolinkages. So, this is isolinkage. In this isolinkage, we are adding what? CH2OH. So, common name is isobutyl alcohol. Isobutyl alcohol. This is the common name. Then what will be the IUPAC name? So numbering 1, 2 and 3. 2 position there is methyl, 1 position there is all. So we will write all is the functional group. So we will write 2 methyl, 2 position there is methyl. 2 methyl, 1, 2, 3 carbon atom in a chain. Prop system. So propan. Propanol also we can write or propan-1-ol. Both are allowed. Propanol and propan-1-ol. Now ये जो ब्यूटाइल सिस्टम है, इसका जो रिंग का स्ट्रक्चर है, चेन का स्ट्रक्चर है राधा, इसका स्ट्रक्चर थोड़ा चेंज करके उसको ऐसे बनाते हैं तो ये टर्शियरी बन जाता है क्योंकि कार्बन एटम जिसके साथ OH अटैच्ड है, द कार्बन एटम टू विच द OH इज अटैच्ड or A is connected to 3 other carbon atom, and it is a 3-degree system. So it is actually tertiary butyl alcohol. Tertiary butyl alcohol is the common name. What should be the IUPAC name? You number it anyway. It comes out to be longest carbon chain you have to select. Otherwise, you will get only 2 carbon atoms having OH. So first go for the longest carbon chain having the functional group. So it is like this. The name is 2-methyl, 2 position there is a methyl. So 2-methyl, 3 carbon atom in a chain. So propan, 2 position there is all. So propan 2 all. Next, if I have more than one OH, that means polyhydric में what it will be. This structure and this compound both are very famous. For your solution chapter you have seen. You have seen this. This is ethylene glycol. So ethylene glycol, जो लोग solution chapter को complete किए हैं उन्हें पता है कि ethylene glycol, which is the common name, is an antifreeze. And you see it is polyhydric, it has more than one OH. So it will be like there are 2 carbon atoms in a chain having 2 OH groups. So here I will not drop the E. I will write ethane. 2 carbon atoms are there. 1, 2. How many OH are there? 2. So diol. O is not there. Your D is there. So E is remaining. D is not a vowel. So ethane 1, 2 diol. Moreover, remember in this manner that if there are more than one OH group, then if it is not monohydric, if it is polyhydric, for those cases you will write alkane and then you mention diol or triol, whatever. So let us see another one. CH2, sorry, not a CH2. This will be CH. Okay, so now CH2. Why? Because the reason is I am adding 1 and 2 and a 3 OH groups. The common name is glycerol. This is the common name. And 1, 2, 3 carbon atom. So it is a propane system. So propane 1, 2, 3. 3 are there. So tri. And for the alcohol, all. So this is your IUPAC name. Propane 1, 2, 3 triol. If I have cyclic alcohol, suppose the OH group is attached to any cyclic system and not necessarily benzene, then it's not a phenol now, it's alcohol. So we will use the prefix cyclo, considering that the OH group is attached to carbon number 1. So this will be prefix cyclo, cyclohexane. But in hexane, carbon number 1, there is all. So I will say cyclohexanol. I am replacing E by all. Suppose I give a substituent to this system and this time I am keeping a 5-membered ring. This is OH and this is CH3. So now again I have to give carbon number 1 to the carbon having OH. Obviously the next one is carbon number 2. So here at carbon number 2 I have methyl. So it will be 2-methyl, then a cyclo prefix and then the alkane where E is replaced by all. So cyclopentanol. This is the IUPAC name. Now for phenols. For phenols we can say like phenol ke liye this name is allowed. You can write phenol. So let us see the structures. Phenol mane benzene ring having OH. So I have already told you this is a phenol system. Benzene ring having OH. It's a phenol system. To this system, suppose I gave a CH3 in its ortho position. This is the ortho position of phenol. Now to this ortho position I have given one CH3. So its common name is O-cresol. O means ortho and cresol goes for methyl phenols. All methyl phenols are known as cresols. Now if it is in the ortho position, the name is O-cresol. But this is your common name. What is your IUPAC name? In the 2 position there is methyl. So we will say 2-methyl phenol. This is the IUPAC name. Now if I change this CH3 from the ortho position to the meta position, then I will see it is M-cresol. In case of CH3 in the meta position, the common name is M-cresol because CH3 is in the meta position. Then what will be its IUPAC name? CH3 is in position 3. So it is 3-methyl phenol. To the phenol system, in the 3 position, there is methyl. So what will be P-cresol? Do it yourself before I complete. P-cresol, OH, 1 and P position, para position is this. This is CH3. So this is your para position and so the common name is P-cresol. It's your common name for the compound and the IUPAC name will be 4-methyl phenol. This was the phenol, substituted phenol. Suppose the phenol system as substituent it is not having any other any other groups. If I have dihydroxy derivatives of benzene, dihydroxy derivatives of benzene means benzene is the parent and I am having one OH, then it becomes phenol. But now I am having another OH. So this is in the ortho position. The positions are 1-2 position. There is a common name for this. It is known as catechol. This is your common name for the compound. And the IUPAC name will be, this is benzene as parent. And there are more than one OH. So it's a polyhydric system. Such a system is named in this manner. Benzene 1-2 position, there are 2, so di. 2, what is there? All is there, diol. Now, this again, if I have not in the 2 position, but say in the 3 position. So this is 1, this is 3. This was catechol and here the name is resorcinol. Resorcinol, that's a common name. And the IUPAC name is again benzene is the parent. So IUPAC name is benzene. 1-3, there are 2, so di OH, all. I change the position, bring it down to 4 position. Then this is OH, 1 position, 4 position is another OH. Now this is a quinol system. It's a quinol or it's also known as hydroquinone. These are the common names and the IUPAC name will be 1 and 4 positions. Benzene 1-4 diol. Now naming of ethers. When we name ethers, we have to name them as alkoxyalkanes. Alkoxyalkanes. Now keep in mind that this alkoxy is the derivative substituent and alkane is the parent chain. This system should contain greater number of carbon atoms. Suppose I say ROR dash. It's of course unsymmetrical ether. and I say R dash contains more number of carbon atom than R, then this part will be my alkoxy part because it's containing R is containing less number of carbon atom, and this will be the alkane part. Alkane part. So likewise we have to name them. Let us see. The simplest possible naming is CH3OCH3, 1 carbon atom on both the sides. It's an example of symmetrical ether. Common name is dimethyl ether because there are two methyl groups in the ether linkage. So dimethyl ether. But IUPAC name will be alkoxy alkane type. So when I say alkoxy, this part is your alkoxy and it contains only 1 carbon atom. So it is methoxy. Methoxy, parent is also having 1 carbon atom, parent chain. So it will be methoxy methane. Go to the next example. Suppose I have CH3, CH2, O, CH2, CH3. Both the sides same. So the common name will be diethyl ether. Diethyl ether. And what will be the IUPAC name then? IUPAC name will be ethoxyethane. Ethoxyethane. Now if both the sides there are different, like CH3, O, CH2, CH3, this part is containing more number of carbon atoms, the other part will be acting as methoxy group, alkoxy group. So what will be the common name? Common name will be methyl ethyl ether, or I will say yes, ethyl methyl ether as well. But what will be the IUPAC name? Okay, IUPAC name will be methoxy, 2 carbon atom. So ethane. And here ethyl, because E comes first. Ethyl methyl ether. So this is your common name. See, here important is the IUPAC name, and how you are supposed to name it, I have already told you. Now, after this, suppose some common names which are actually very common. Let us see. One such common name is anisole. Anisole. Very often used. You can see what is anisole. Anisole is a benzene ring having OCH3 is anisole. So I can say C6H5OCH3 is anisole. So here I can name it as methoxybenzene. Anisole is methoxybenzene and this is your methoxy. After this I can say phenitol, common name, phenitol. Now phenitol का structure क्या है? C6H5, there will be a phenyl ring, OCH2CH3. This is OCH3. In place of OCH3, it is OCH2CH3. So this was methoxy. Methoxy के जगह पे यहाँ आ जाएगा ethoxy. So it will be ethoxybenzene. Ethoxybenzene. This is your IUPAC and this again is your IUPAC. Now suppose I say another example I am giving. Common name is methyl isopropyl ether. Methyl isopropyl ether. From the common name we know that on both the side of oxygen there is one methyl and there is one isopropyl. So this is oxygen. Let me make one methyl and another side isopropyl. So this is your isopropyl group. Iso linkage is this part is your iso linkage. So what will be the IUPAC? I have to search for the longest carbon chain. So 1, 2, 3. 2 position there is methoxy. So the IUPAC name is 2-methoxypropane. 2-methoxypropane is your IUPAC for the structure. So this is how you are going to name the compounds. Suppose one last example let us see. For this, a cyclic system, not a benzene. Note that there are 2 CH3 and there is 1 OC2H5. So 1 ethoxy is there. So this is present in carbon number 1 because it is a functional group. OR system, ether. So next to it is carbon number 2. So this is 1 position there is ethoxy and 2 position there are 2 methyl. So I will say 1 ethoxy 2, 2 dimethyl cyclohexane. Now I have to check that when I have done so, let me see how many carbon atoms or what positions are involved. Here carbon number 1 there is 1 functional group. Carbon number 2 there are 2 functional groups. Summation comes out to be 5. If I try to apply the lowest locant rule. If I number it the other way means suppose I number this one and this as 2. So the name changes though. Name becomes what? It becomes 2-ethoxy and then in carbon number 1 there are 2 methyl for this way of numbering. 1 dimethyl cyclohexane. So since you are taking cyclohexane as the parent, this way of numbering is allowed. For this we will see 2 plus 1 which is 4 and is less than 5 following lowest locant rule. This can be your IUPAC name. So this is all. We can practice some more for more IUPAC. So I said to see NCERT questions. So let us see NCERT in-text question, and that is in-text question number 3. There in text question number 3, in the first one we are seeing CH3, CH2, CH, and here there is a CH2Cl, here there is CH, here there is CH2OH, see where OH is there, and a CH, CH3, CH3. Now your work becomes little difficult in order to search for the longest carbon chain, the main carbon chain. So if I say I have to include the OH in it, then my way of numbering goes 1, 2, 3, 4, 5. Now I am having 5 carbon atoms where carbon number 1 is having one all. Carbon number 3 is having a chloromethyl and carbon number 2 is having this group which is isopropyl. So this iso linkage is in carbon number 2. So here we can say it is 3-chloromethyl because C comes first. So I will say 3-chloromethyl. Then it comes to position there is isopropyl. So 2 position there is isopropyl and then 5 carbon atoms pentan, 1 position all. So I can say pentanol or pentan 1 all. This is the first one. Second one what we can see is another type. This is one type. The second one is telling that there are more than one OH. So CH, see here CH3, CH2, CH, OH, next to it is CH, then there is a CH2OH, next to it there is a CH3. In this system, clearly we can see there are more than one OH groups attached. So it's a diol system. Moreover, we have a methyl here, and let us try to find, is there any other methyl over here attached? How we can number the main chain? So the main chain can be 1, 2, I have to go left, 3, 4, 5 and a 6. And of course it's having a diol and another methyl discovered. So another 2 methyl and 2 all are there. So it is actually 2, 5, 2 methyl are there. So dimethyl, main chain alkane is hexane. So hexane 1, 3 diol. Here E needs to be maintained because di and tri, for that we keep the E. So I hope this was quite clear to you. Practice, practice, practice makes a man perfect. Of course, I will use the term practice makes us all perfect, be it man or woman. Now, going to third one. Third one says there is a cyclic system. There is OH and there is Br. साइक्लिक देख के ही दिमाग में बेंजीन 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 नहीं आना चाहिए. यहाँ पे पाई बॉन्ड नहीं है. So let us see. The carbon number 1 is this. Carbon number 3 is this. So now I will say how to name it. 1 position OH, 3 position Br. So it's a cyclohexanol system. 3 position में ब्रोमो है. So 3 bromo cyclohexanol. Okay, if you have done it, then it's a great job you have done. Congratulations. Going to the fourth, let us see. CH2 double bond CH, single bond CH, OH and a CH2 and a CH2 here and another CH3. If you understand, please mention, ma'am, we have understood. That will make a virtual platform interactive. So utilize the virtual platform for interaction purpose as well. I expect this much of responsibility from all my viewers. They can at least drop a comment saying, ma'am, we understood. Okay, so now let us see this part. There is a double bond. There is a double bond and all system. How do I name it? So it is to be numbered from the left hand side. Double bond is there. So 1, 2, 3, 4, 5 and 6. So here we can see it's a hex system. Had it been only 6 carbon atoms with a double bond between 1 and 2, it is hexene. So similarly, this is also hexene system, but there is all. So I will write hex 1, N and 3 all. Why? In an alkene system, if there is an alcoholic OH group attached, we drop the E and we write it as alkenol. That is what is being done. Hexene system 3 position all. So it is hex 1N 3 all. Next, we have another example. Say if I say this one, fifth one, this is the last one of this intext question. CH3, CCH3 double bond CBr CH2OH. Now, here we see left or right to number. If we number from left, then also it's position 2. If we number from right, then also it's position 2. So obviously we have to number from right because there is one OH here. So it is 1, 2, 3 and a 4. So it is 2 position there is a bromo, 3 position there is a methyl. So we will say 2 bromo, 3 position there is a methyl. So 3 methyl and there are 4 carbon atoms. Bute system with a double bond. Butene system. Double bond is at position 2, 3. So 2 N 1 all. Here we can also write 2 enol. If I don't write 1, it is 2. I hope this part of the session was useful and beneficial to you. If you think, yes, I could be of little help to you also, do drop a comment in the comment box, which will be motivating me. We all need motivations, right? We all need positive vibes. So do feel positive, do radiate positivity. That's my message for today. Feel positive, make your surroundings positive. Until and unless you are positive, nothing positive can happen. So now let us radiate positivity.